Mr. Contractor hires some workers on daily wage basis. The hired workers are categorized into three different grades with non-skilled, skilled and supervisory. So we have non-skilled, skilled and supervisory. Following table gives the number of workers in each grade, the number of workers in each grade, and using three different formulas given in the table, he calculates the daily wage payable to the workers. So these are the three formulas. Also remember that here greatest integer function is involved. So it is involved in the case of supervisory. So this is the main part of the question that is given to us. Now let's look at the question that has been asked. The question is, what is the minimum possible number of workers excluding the number of supervisors? So we need to exclude the number of supervisors. It means this row is of no use to us. Okay, it is not going to be used. That can be hired by Mr. Contractor so that a non-skilled worker gets as much amount of money as his daily wage as a skilled worker gets. So the wage of a non-skilled worker should be same as the wage of a skilled worker. Okay. That means W of X should be equal to W of Y. So from the question we can understand that W of X should be equal to W of Y, where X represents the number of non-skilled workers and Y represents the number of skilled workers. So for what value of X and for what value of Y, W of X and W of Y are going to be same, they are going to be equal. And for those cases we need to take the sum of X and Y so that it can be minimized the total number of workers, excluding the supervisor of course. So that means we have max of 75 and 153 minus 3x. This should be equal to max of 120, 310 minus 10y. So we do not know which one is the maximum out of 75 and 153 minus 3x in this. And similarly on the RHS, we do not know which one is greater, 120 or 310 minus 10y. So if we look at the values, so we need to compare W of X with W of Y. Sorry, WX with W of Y. So 75 needs to be compared with 120, 75 needs to be compared with 310 minus 10y, 153 minus 3x should be compared with 120, and 153 minus 3x should be compared with 310 minus 10y. Okay, what kind of comparison are we looking at? We are looking at equality. So let's do the first thing, the first case. So there are four cases going to be possible. So let's look at the first case. 75 is equal to 120. Doesn't make any sense. Ruled out. Case 2. 75 is equal to 310 minus 10y. Or we can say that 10y is equal to 235. Or y is equal to 23.5. So y is the head count, right? This is the total number of workers. So obviously the answer cannot be in decimal point. So this is ruled out again. Let's look at case number 3. Case number 3, let's compare 150 minus 3x with 120. So we'll have 153 minus 3x is equal to 120. Or we will have 3x is equal to 33 or x is equal to 11. So x is equal to 11. So we get the value of x. Now, if we look at the second one, we will have, we have understood that 120 is the maximum. But we should have a value of y such that we will let 120 to be maximum. So 310 minus 10y in the case 3, we have already obtained x is equal to 11 because we compared it with 120. So we are taking 120 to be the maximum of these two values. So we need a value of y such that 310 minus 10y is 120 or less than 120 such that 120 over here is the maximum of both of these. Hence this comparison was feasible or possible, right? So let's take 310 minus 10y should be less than or equal to 120, because max of 120 and 120 will be 120 only. So we will have 10y is greater than equal to 190, or we will have y is greater than equal to 19. So what is the minimum possible value of y? We have minimum value of y is 19. So how many total number of non-skilled laborers do we, non-skilled workers do we require? 11. And how many numbers of skilled workers do we require? 19. So the minimum value of x plus y in case 3 comes out to be 11 plus 19, that is 30. Now let's look at case number 4. Case number 4 is the comparison between 153 minus 3x and 310 minus 10y, considering they both are the max among their corresponding functions. So 153 minus 3x is equal to 310 minus 10y. And solving this, we will have 10y minus 3x is equal to 157. Now, we require minimum possible of x and y such that this equation holds, as well as x plus y is minimum as well. Okay. With a little hit and trial, we can see that we need to put y as maximum as possible such that it reaches closest to 157. So if we take y as, let's say, 16, so this value becomes 160. So how much do we need to subtract from 160 to get 157? We require 3 to be subtracted. So in order to get 3, the value of x should be 1. So this is the minimum, because if I take y is equal to 17, x comes out to be 13. So the value of x and y will keep on increasing as we increase the value of y. And the value of y can never be 15, because 10 into 15 gives us 150, and we need to reach up to 157. X not being negative. So we always need to subtract. So looking at this, we can say that x and y minimum is going to be 17 when y takes a minimum of 16 and x takes a minimum of 1. So 17 is the minimum value. So out of the two values that we have received, 17 comes out to be the minimum. So the answer is D. D is the right answer.